day, everyone. So, our group will talk about the chapter 5 entitled Business Analytics at the Data Warehouse Level. I would like to introduce the magnificent reporters of this chapter.
Good day, everyone. I am Trisha Ann Cazeñas, and I am your first reporter for Chapter 5 Business Analytics at the Data Warehouse Level.
Good day, everyone. I am Josh Alexander Albonian, and I'll be the one to report the data warehouse, functions, components, and examples.
Good day, everyone. I am Kathlene and Oloroso, and I will be reporting the tips and techniques in data warehousing and how should data be accessed.
Companies today are really excited to dive into new data activities, whether it is artificial intelligence, machine learning, or even advanced analytics. But not until they realize that data preparation is absolutely crucial in order to be able to do this work. It is kind of like pushing a wheelbarrow without any wheel. You can do it, but it's going to be really hard, and you will probably strain something in the process. The organization needs a data warehouse. So what is a data warehouse? A data warehouse is a centralization of all the different data sources coming from whether in accounting system, an ERP or enterprise resource planning, or even spreadsheets, and you make a copy of it in a centralized location. Why do we need to make a copy? Because by putting everything in a single location, you can also set up a set of rules to help you with things such as identifying when to pull the data, ensuring that the data is in consistent format, and also dealing with things like conflicts if two different data sources are actually pulling to the same location. Once a company has all of this in place, they have now built a central repository that can be used by anyone looking to do artificial intelligence or advanced analytics for better decision making. A data warehouse is a means to an end. It allows companies to really open up new doors in terms of becoming more efficient and much faster at doing the analysis. So probably you are asking, why a data warehouse? The point of having a data warehouse is to give the organization a common information platform which ensures consistent, integrated, and valid data across source systems and business areas. This is essential if a company wants to obtain the most complete picture possible of its customer. What do we mean by a 360-degree view? A 360-degree view of a customer is a collection of all your customer data in one place. This is very helpful to different companies since utilizing a 360-degree view can make them adjust or position themselves in predicting the current and future needs of their customers. In order to gather information about our customers and to generate a 360-degree profile, we have to join information from a large number of independent systems. Independent systems are the systems where we can get information to acquire a 360-degree view. The first one is the billing systems. These are procedures and processes that help create bills and invoices for customers. Example, our system printing bills. The second one is human resources information. Examples in company, these are information about employees, timesheets, their competencies, and history. The third one is product and purchasing information. Example, products and services a customer has purchased over time. The fourth one is customer information. Example, names, addresses, opening of accounts, cancellations, special contracts, and segmentations. And last one is weblogs. Information about customer behavior on our online portals. Example are those text files stored on your web server. A data warehouse consists of a technical part and a business part. The technical part must ensure that the organization's data is collected from its source systems and that it is stored, combined, structured, and cleansed regardless of the source system platform. This means that it focuses more on the data process within the organization. The business part, on the other hand, must ensure that the desired key figures and reports can be created. This part focuses more on the output as a result of the data processes. So there are many good arguments for integrating data into an overall data warehouse. This includes to avoid information islands and manual processes in connection with the organization's primary systems, to avoid overloading of source systems with daily reporting and analysis, to integrate data from many different source systems, to create a historical data foundation that can be changed or removed in the source systems. Example, saving the orders historically even if the enterprise resource planning or ERP system deletes open orders on invoicing. To aggregate performance and data for business needs. To add new business terms, rules, and logic to data. Example, rules that do not exist in source systems. To establish central reporting and analysis environments. To hold documentation of metadata centrally upon collection of data. To secure scalability to ensure future handling of increased data volumes. And lastly, to ensure consistency and valid data definitions across business areas and countries. This principle is called one version of the truth. Next is the architecture and processes in a data warehouse. So we will now discuss the data warehouse based on the direction in which data and information actually move, which is from bottom to top, as you can see in an enterprise data warehouse in Exhibit 5.1. As is shown by the arrow, the extract, transform, and load or the ETL processes create dynamics and transformation in a data warehouse. We must be able to extract source data into the data warehouse, transform it, merge it, and load it to different locations. So what does ETL means? It is a data integration process that combines data from multiple data sources into a single consistent data store that is loaded into a data warehouse or other target system. ETL is a data warehouse process that always includes these actions. First, extract data from a source table. So for the first part of the ETL process, we have the extraction. May it be from a source table, staging table, or from a table within the actual data warehouse. The second one is transform data for business use. It is the transformation phase wherein a series of business rules or functions are used on the extracted data. And the third one is load to target table in the data warehouse or different locations outside the data warehouse. This means that after the extraction and transformation of data is the loading phase of the ETL process, wherein data is entered in the data warehouse or moved from one area of the data warehouse to another. So, we will move on to the selection of certain columns to be loaded. It is necessary to choose the columns that should be loaded, and here are the following. First is the translating coded values. For example, the source system is storing M for man and W for woman, but the data warehouse wants to store the value 1 for man and 2 for woman. Next, mapping of values. For example, mapping of the values man to M and Mr. into the new value 1. Next, calculating a new calculated value. For example, sales is equals to number times unit price. Next, joining from different sources. For example, to look up or merge. Next, summing up of several rows of data. For example, total sales for all regions. Next, generating a surrogate key. This is a unique value attributed to a row or an action in the database. The surrogate key is not in the source system. It is attributed by the ETL tool. Next is transposing, changing multiple columns to multiple rows or vice versa. Next, we have the simple ETL job and the complex ETL job. In the illustration, you can see a simple ETL job where data is extracted from the source table or the staging, then the selected fields are transferred to the temporary table, which through the load object is sent on the table or the staging in the staging area. The transformation of the job is simple, since it is simply a case of selecting a subset of the columns or fields of the source table. The load procedure of the ETL job may overwrite the old rows in the target table or insert new rows. This time, take a look at this more complex part of an ETL job. Here, data is extracted from 3 staging tables. These 3 temporary tables in the center of illustration are joined using structured query language or SQL. So what is SQL or structured query language? It is a programming language used when manipulating data in a database or a data warehouse. SQL join may link information about position, unemployed, employee, or self-employed to information about property evaluations and lending information. There may also be conditions or business rules that filter out all non-corporate customers. The procedure is a transformation and joining of data which ends up in the temporary table or the temporary table 4. The table with the joined information about loan applicants, again in temporary table 4, then flows on in the ETL job with further transformations based on the business rules until it is finally loaded to a target table in the staging area, the actual data warehouse, or for reporting and analytics in a data mart. Staging area and operational data store. ETL processes transfer business source data from the operational systems, example, the accounting system, to a staging area, usually either raw and then processed or transformed by means of simple business rules. So what is operational data store or ODS? This will enable business users to access data instantly. Staging area. It is a temporary storing facility in the area before the data warehouse. So, from those given source system wherein we are able to get our data, we will going to staging area through the ETL process. So that temporarily, it will store data coming from the source system. Different types of formats on databases. First one is the Oracle. It is a database commonly used for running online transaction, processing, data warehousing, and mixed data workloads. Next is the DB2 or Database 2. It is relational databases enable enterprises to create declarative data models accessible via queries. Next is the SQL Server or software product with a primary function of storing and retrieving data as requested by other software applications which may run either on the same computer or on another computer across a network. Next is the MySQL. It creates a database for storing and manipulating data, defining the relationship of each table. Clients can make requests by typing specific SQL statements on MySQL. The server application will respond with the requested information and it will appear on the client side or SAS, Statistical Analytics Software. This means to retrieve, report, and analyze statistical data. Lastly, flat text files known as a text basis is a type of database that stores data in a plain text format. Example, if the business needs to access data with only a few minutes delay, for example, because the content are risk calculated on the portfolio values of the bank, they need to implement ODS or the operational data stores. Causes and effects of poor data quality. So what is data quality? It is a result of how complete the data is, whether there are duplicates, and the level of accuracy and consistency across the overall organization. It is also central in all data integration initiatives. Organizations know that correct data, example, complete and accurate customer contact data for CRM, is very essential to achieve a positive return on these investments. Therefore, they are beginning to understand the significant advantage that is associated with focusing on data quality at a strategic level. Data from a data warehouse cannot be used in an efficient way until it has been analyzed, and cleansed. To ensure that poor data quality from external sources does not destroy or reduce the quality of internal processes and applications, organizations should establish this data quality firewall in their data warehouse. So, what is this actual storage facility or a firewall? The firewall can analyze incoming data as well as cleanse data by means of known patterns of problems, so that data will be of a certain quality before it arrives in the data warehouse. The data quality firewall must keep data of poor quality out of internal processes and applications. Poor data that cannot be cleansed will be rejected by the firewall. Causes of poor data quality. First, manual data entry errors. Humans are prone to making errors, and even a small data set that includes data entered manually by humans is likely to contain mistakes. Data entry errors such as typos, data entered in the wrong field, missed entries, and so on are virtually inevitable. In short, they are all human errors. The second one is the OCR errors. Machines can make mistakes when entering data too. In cases where organizations must digitize large amounts of data quickly, they often rely on optical character recognition or the OCR. Machine errors like OCR, technology scans images and extracts text from them automatically. It can be very useful when, for example, you want to take thousands of addresses that are printed on paper and enter them into a digital database so you can analyze them. The problem with OCR is that it is almost always imperfect. If you are OCRing thousands of lines of text, you are almost certainly going to have some characters or words that are misinterpreted. Zeros that are interpreted as 8s, for example, or proper nouns that are read as common words because the OCR tool fails to distinguish properly between capital and lowercase letters. The same sorts of issues arise with other types of automated machine entry of data, such as text-to-speech. The third one is the lack of complete information. When compiling a dataset, you frequently run into the problem of not having all information available for every day. For example, a database of addresses may be missing the zip codes for some entries because the zip codes couldn't be determined via the method that was used to compile the dataset. The fourth one is the ambiguous data. When building a database, you may find that some of your data is ambiguous, leading to uncertainty about whether, how, and where to enter it. For example, if you are creating a database of phone numbers, some of the numbers you seek to enter may be longer than the typical 10 digits that you have in a United States phone number. So you will have this question in your mind. Are those longer numbers simply typos, or are they international phone numbers that include more digits? In the latter case, does the number contain complete international dialing information? These are the sorts of questions that are hard to answer quickly and systematically when you are working with a large body of data. Fifth one is the duplicate data. You may find that two or more data entries are mostly or completely identical. For example, maybe your database contains two entries for a John Smith living at 123 Main Street. Based on this information, it's difficult to know whether these entries are simply duplicates. Maybe John Smith's information was entered twice by mistake, or if there are two John Smiths, a father and a son, perhaps, living at the same address. You need to sort out seemingly duplicate entries like this to make the best use of your data. The sixth one is the data transformation errors. Converting data from one format to another can lead to mistakes. As a simple example, you may have a spreadsheet that you convert to a comma-separated value or the CSV file. Because data fields inside CSV files are separated by commas, you may run into issues when performing this conversion in the event that some of the data entries in your spreadsheet contain commas inside them, unless your data conversion tools are sufficiently smart. They won't know the differences between a comma that is supposed to separate two data fields and one that is an internal part of a data entry. This is a basic example. Things get much more complicated when you must perform complex data conversions, such as taking a mainframe database that was designed decades ago and converting it to NoSQL, a category of database that has become popular in just the last few years. So now, we will go on to effects of poor data quality. Number 1. Poor data quality is very costly and can cause breakdowns in the organization's value chain. Example, no items in stock and can lead to impaired decision-making at management and operational levels. The second one is, equally, it may lead to substandard customer service, which will cause dissatisfaction and cancellation of business. Number 3, lack of trust in reporting is another problem that will delay budgeting processes. The fourth one, poor data quality affects the organization's competitiveness negatively. So after we have identified the causes and effects of poor data quality, here in the next phase, we will going to discuss the improvement of data quality, wherein we will now going to find ways on how we will improve our data in order for our business to maintain its efficiency and productivity. So, the first step towards improved data quality in the data warehouse will typically be the deployment of tools for data profiling. The process starts with the development of the better data. This means correcting errors, securing accuracy, and validating and standardizing data with a view to increase their reliability. Based on data profiling, tools introduce intelligent algorithms to cleanse and improve data. The first one, by means of advanced software, basic statistical analysis are performed to search for frequencies and column widths on the data in the tables. So based on the statistics, we can see, for example, frequencies on non-existent or missing postal codes, as well as the number of rows without a customer name. Using this technology means that duplicate rows can often be removed so that customers appear only once in the system. Rows without customer names can be removed. The second one is incorrect values of sales figures in transaction tables can be identified by means of analysis of numeric widths of the column. Data with incorrect postal codes can be corrected or removed. The third one is the algorithms searching for different ways of spelling the same content are carried out with the purpose of finding customers who appear under several names. For example, Mr. Thomas D. Marchand could be the same customer as Thomas D. Marchand. Is it the same customer twice? Using this technology means that duplicate rows can often be removed so that customers appear only once in the system. So, the fourth one is software packages can disclose whether data fits valid patterns and formats. Phone numbers, for instance, must have the format 311-555-1212 and not 311-555-1212. Phone numbers are adjusted to the desired format with the format of XXX-XXX-XXX. Data cleansing is a process that identifies and corrects or removes ruined or incorrect rows in a table. The actual data cleansing process may involve a comparison between entered values and a known list of possible values. So, we have validation of cleansing. The validation may be first hard, so that all rows without valid postal codes are rejected or deleted. Or it can be soft, which means that values are adjusted if they partly resemble the listed values.
Good day everyone, I am Josh Alexander Albonian and I'll be the one to report the data warehouse, functions, components, and examples. Alternative ways of storing data and business analytics portal, functions, and examples. Let's start with the data warehouse, functions, components, and examples. In the actual data warehouse, the processed and merged figures from the source systems are presented. A modern data warehouse typically works as a storage area for the organization's dimensions, as well as a metadata repository. First, we'll look at the dimensions of the business, and then we'll explain the concept of the metadata repository. From the staging area, the data sources are collected, joined, and transformed in the actual data warehouse. One of the most important processes is that the business transactions are then enriched with dimensions, such as organizational relationship, and placed in the product hierarchy before data is sent onto the data mart area. This will then enable analysts and business users to prepare interactive reports via slice and dice techniques. As a starting point, a business transaction has no dimensions when it arrives in the data warehouse from the staging area. That means that we cannot answer questions about when, where, who, what, or why. A business transaction is merely a fact or an event, which in itself is completely useless for reporting and analysis purposes. An example of a meaningless statement for an analyst is, our sales were $25.5 million. The business will typically want answers to the questions about when, for what, where, by whom, for whom, in which currency. And dimensions are exactly what enable business users or the analyst to answer the following questions. When did it happen? Which year, quarter, month, week, day, or time? Where and to whom did it happen? Which salesperson? Which department? Which business area? Which country? What happened? What did we make on which product? And on which product group? All these questions are relevant to the analyst. Dimensional modeling is a popular way of organizing data in a data warehouse for analysis and reporting, and not without reason. The starting point is the previously listed transactions or facts. It may also be helpful to look at the organization's facts as events. These fact rows are enriched with dimensions in a data warehouse to provide perspective. The dimensions in Exhibit 5.4 surrounding the facts or transactions put the sales figures, revenue figures, and cost figures into a perspective. This type of illustration is also called a star schema. Among other things, it gives business users and analysts the opportunity to get answers from the data warehouse, such as these. Our sales in product group 1 in December in the United States, measured in the currency US dollars, were 2 million. Sales in Department 2 of Business Area 1 in the first quarter in Europe, measured in the currency euros, were 800,000. Note that the dimensions answer questions about when, for what, where, for whom, and by whom. Business reality is viewed multidimensionally to create optimum insight. Generally speaking, the multidimensional perspective enables the business to answer the question, why did things turn out as they did? Organization consists of a number of business areas. Under each of these areas, we've got a number of departments, and each department we've got a number of employees. These hierarchies provide us the opportunity to slice and dice the information. A sales figure for the overall organization can be broken down into business areas. Each business area can be broken down into departments, and the department figures can be broken down into individual employees. Note that these features are especially helpful when the business, on a daily basis, is analyzing information by itself and is therefore not drawing on quantitative analyst resources. A modern data warehouse will normally contain a metadata repository. Here, information is stored about business data. The simplest definition of metadata is data about data. For example, for a camera, a data is a digital photo. Metadata will typically contain information about the date the photo was taken, the setting of the camera, name of the manufacturer, size, and resolution. Metadata facilitates the understanding of the data with a view to using and managing data. Metadata has been given a central role as businesses are becoming increasingly demanding of documentation. The documentation of data and tables is of equal importance, and the demands for metadata registration in the data warehouse have grown considerably in recent years. Previously, it was sufficient if tables and fields had meaningful names. The simplest way to create metadata about tables and fields is to give these meaningful names. Many BA vendors have taken action on the consequence of customers' need for advanced metadata registration and search options for the average user. They have created one single metadata layer in text format, XML format in fact, that points to physical tables, fields, users, servers, programs, and reports. This layer can be found in the metadata repository of the data warehouse. What is XML? The Extensible Markup Language. It's a simple text-based format for representing structured information, documents, data, configuration, books, transactions, invoices, and much more. The metadata repository has become one of the BA vendors' most important upgrading and sales arguments, and the arguments are compelling. The metadata layer produces documentation about everything that goes on in the data warehouse and the front-end portal. Some software developers are working along the lines that reports cannot be produced if they are not registered in the metadata repository of the data warehouse. Similarly, a physical table is not available to the reporting environment without metadata registration. The same situation occurs with users, servers, and so on. A metadata repository has become key, since all web inquiries must go through the metadata layer via the metadata server. This results in visibility and documentation of everything that goes on, and this is considered increasingly important to businesses. These days, it's almost unthinkable to build a data warehouse structure without a central metadata repository. In the top layer of the BA platform, where users access reports and data, this metadata repository also enables users to search on data definitions and reports from the web interface as if they were books at the level. The users of Apple's iTunes software know about metadata registration in XML format. An XML file on iTunes library on a personal computer contains all the information about tracks, albums, and artists, and so forth. iTunes uses this vital file to navigate. If an iTunes user copies one MP3 music file with Microsoft Explorer to a physical music library outside iTunes, it won't appear in the user's iTunes music collection, and he or she won't be able to search for it or play it, because information about the existence of the file and data is not metadata that is registered via his or her iTunes software. Data marts for the support of business processes are the end products delivered by the data warehouse and thus contain information for business users. A data mart is a specialized version of a data warehouse. Like a data warehouse, a data mart is a snapshot of operational data to help business. The difference between a data mart and a data warehouse is that data marts are created based on their particular reporting needs of specific, well-defined user groups, and data marts provide easy business access to relevant information. A data mart thus designed to answer the user's specific questions. Relevant dimensions for the business area have been linked to data, and specific business rules apply to help users move about in the desired dimensions and hierarchies. An organization may have several data marts for different functions, such as marketing, sales, finance, human sources, and others. A data mart is normally structured as a dimensional model, such as star schema, made up of fact tables and dimension tables, and using specific business rules. An online analytical processing, or OLAP cube, or pivot table is a way of arranging data in areas to facilitate quick data analysis and is often used for data marts. The arrays are called cubes. An organization may have many data marts, each of which might be relevant to one or more business units for which they have been designed. Many business units have assumed ownership of their data marts. This ownership enables each business unit or department or business's area to use, manipulate, and develop their data to suit their needs, without changing any information in other data marts or centrally in the data warehouse. Another reason for gathering data in small marts is that time is saved in connection with queries, simply because there is less data to process. This means that two different data marts may present exactly the same information, except that one presents it in much more detail, which can be used if the user decides he or she needs detailed information. When data has been joined and enriched with dimensions in the data warehouse, the data can be extracted for business use to data marts. These ETL processes will use many different business rules according to individual user needs. A data mart may cover the accounting functions need for a consolidated set of figures with the specific business rules required. Another data mart may cover the need for a performance monitoring of the organization's sales and processes. As stated previously, the database for data marts may be relational or OLAP cubes. The functional difference between these two types of data is of great significance to analysts and business users. Among other reasons, because the difference affects response times and analytical scope. A relational data model is a model where data is organized using common characteristics. The order of the rows doesn't matter. Only the number of rows is important because the number affects how quickly extracts can be performed. The order of the columns is no importance either. Transaction-based tables are always relational, as explained in the following section. For adding, processing, and extracting data from relational tables, we use the programming language SQL, which is a formalized way of talking to databases. If we want to know the bookshop's revenue distributed on the types paperback and hardback, we can send the following SQL syntax off to the database. SQL or structured query language is a domain-specific language used in programming and designed for managing data held in a relational database management systems, or RDBMS, or for stream processing in the relational data stream management system, or R. Large enterprises such as Walmart have several 100 million transactions a year. And it doesn't take a lot of imagination to see that response times in reporting can be very long if a preceding summary of the relational tables is not carried out, or if a reporting mart with a database in the shape of an OLAP cube is not created. Once the OLAP cube is created, we can just add another row as relational tables. By using this method of arranging data in cubes, we avoid the limitation of the relational databases, as these are not suitable for instant analysis of large data volumes. The relational databases is more suited for creating rows in a table of a series of transactions. Even though many reporting tools are developed for relational data, these are slow when it comes to summing up large databases. In an OLAP cube, all summing up and calculating are carried out beforehand. We just pull out a value from the cube, so to speak, and we therefore do not need to sum up something like a million rows. The OLAP cube can be seen as an expansion of the word dimensional spreadsheet. A controller will need to analyze financial data by product, by period of time, by town, by type of revenue or cost, and then compare actuals with budget figures. Each of these dimensions may have inbuilt hierarchies. The controller will begin at the summarized level and then perform a drill down or slice and dice in the cube to discover entities, products, salespeople, or periods of time that are accountable for the difference in the total figures. Note that the size of an OLAP cube increases exponentially when more dimensions are added to the cube or when the number of categories in individual dimensions. Alternative ways of storing data. As mentioned earlier, one of the newer trends in data warehousing is the emergence of open source systems like Hadoop. These systems can store large amounts of data on multiple servers. Hadoop systems do not move large data sets to the calculating software. They move the calculating software. This new technology means that cost of software and hardware, which historically has been high when building a data warehouse, in the future might be reduced. Another benefit of Hadoop's file distribution systems is that data can be stored quickly, as it will be in relatively raw format. The downside, however, is that data in this format will continue to be raw. When we have stored the data, we will not be able to change it. With the relatively low cost of storing data using file and distribution systems, organizations have a good way to store data that might be relevant in the future. Should the data, based on the closer examination of data analysts and new business requirements, be considered valuable in the future, it is likely to be moved into a more traditional data warehouse environment. The need for moving this data into an ordinary data warehouse is because the data quality might need to be improved before it can be used. Also, reporting from file distribution systems can be a complex affair, not suited for non-specialists. In addition, a simple look-up query of a single case name, for example, the last produced Peter Pan movie, might take hours in the Hadoop system, as the whole file needs to read before an answer can be given. In the data warehouse environment, the file or table can be indexed, and this will significantly reduce the search time. Business Analytics Portal, functions and examples. BA tools and portals aim to deliver information to the operational decision makers. In most cases, this information comes from relational databases and OLAP cubes in the organization's data warehouse, and the information is presented to business users as scorecards, dashboards, conventional retrospective sales reports, business performance management or BPM, dashboards, and analytical applications. End users access the BA portal on top of the organization's data warehouse. The BA portal constitutes a small part of the overall process to deliver BA decisions support for the business. A rule of thumb is that the portal part constitutes only 15% of the work. 85% of the work lies in the data collection and processing in the data warehouse. In the past, BA tools have been developed from individual applications to serve as critical plugins in the organization's global portals. The requirements for vendors of the BA portals are therefore now focused on their ability to completely integrate all kinds of BA tools into one global portal, which then contains all relevant information for decision makers, whether it be employees, partners, customers. Developments are moving quickly toward global BA portals, and the key to a successful implementation of such a portal that completely integrates BA tools is to acknowledge that the portal is not just the launching pad for applications. The portal must deliver true business value and allow users to access business critical information in a dynamic and secure way. Further, the information must be available via different online and mobile units, all of which must be easy for end users to operate. In the pages that follow, we'll provide examples user-friendly BA front ends and dashboards, which can be accessed on a modern BA portal like the SaaS Information Delivery Portal. These BPM dashboards generated by the SaaS Enterprise BI server enables business users to follow product performance on a monthly or quarterly basis, totaled distribution on different product groups, channels, and the geographical markets where they are sold. The information in the dashboard is log information by nature, but users can, with simple projections based on trends and colors, form an opinion about needs for future performance improvements. In this way, the information can move business process forward too. We get the answers to the questions. The software package includes both pre-built and customized reports, allowing us to gain the most from our data. Built-in analysis allows us to understand how visitors navigate our websites and how they flow throughout user-defined set of pages. In addition to showing the drop-off at each step, the reports track users as they flow into, out of, and through the funnel. The report captures where visitors enter the funnel and where they go once they exit. Expandable and collapsible lists of pages show the most popular customer paths. With text mining analytics, it is possible to classify documents into predefined or data-driven categories, find explicit relationships or associations between documents, and incorporate textual data with structured inputs. The dynamic exploration component helps us discover patterns in large documentation collections and allow us to combine those insights with our predictive analytics to gain maximum value from all of our information. By using text mining analytics, world leaders such as Netanyahu and Obama can find out what's being said about them in forums and lists, and magazine articles and newspapers, as well as on Twitter and on social media sites in real time, and can have it all boiled down and analyzed. To gain an edge in today's competitive market, powerful advanced analytic solutions are required to extract knowledge from vast stores of data and act on it. More and more organizations are turning to predictive analytics and data mining software to uncover patterns in data and discover hidden relationships.
Hello everyone. So this time, we will talk about the tips and techniques in data warehousing and how should data be accessed. But first, let's talk about the tips and techniques in data warehousing. So first, we have MDM, or what we called the master data management. But before that, we should talk about the master data first. Most of the software systems have a list of data that are shared and used by different applications, which makes up the system. And of course, one of these is the master data. Master data is a core data that is absolutely essential for running operations within a business, enterprise, or unit. It is a data about key business entities that provides context for a business transactions and operations. It is not transactional in nature, but it does describes transactions. So master data has four general domains. First is the customers. Under this domain are the customers, employees, and salesperson subdomains. Second is the products. Under this domain are of course the products itself, parts, store, and assets subdomains. And third is the location. Under this domain are the office location and geographic division subdomain. And lastly is the others. Under this domain are the contracts, warranty, and license subdomain. We will now proceed to master data management since you already know what master data is. So what is master data management? It is an intelligent way of consolidating and managing the data. It provides a unified view of data when data is integrated from different source systems as well. And it is a process that creates a uniform set of data on customers, products, suppliers, and other business entities from different IT systems. MDM includes both cleaning and maintaining the master data, investing a lot of effort, money, and time in making the master data clean and consistent is useless unless a solution has a process and tools to keep the master data clean and consistent as it gets updated and expands over time. If a business is growing and expanding, we will expect that the number of applications and systems used across the board will also increase. So these additional databases causes a fracture to the information as different systems create a different version of the same data. So there's no way we can find out which data is incomplete, incorrect, or out of date. To resolve this conflict, MDM ensures the uniformity, accuracy, stewardship, semantic consistency, and accountability of the shared master data assets. In short, MDM enables the business employees to stay aligned, especially in terms of data or information. And now, getting started with the MDM program. Your MDM project plan will be influenced by requirements, priorities, resource availability, time frame, and the size of the problem. Most MDM projects include at least these phases. First, identify sources of master data. This step is usually a very revealing exercise. Some companies find they have dozens of databases containing customer data that the IT department did not know existed. That is why we should always ensure our data is complete to avoid the loss of other important data and information needed in the operation of the business. Second, identify the producers and consumers of the master data. This step involves pinpointing which applications produce the master data identified in the first step, and generally more difficult to determine which applications use the master data. Depending on the approach you use for maintaining the master data, this step might not be necessary. For example, if all changes are detected and handled at the database level, it probably does not matter where the changes come from. Third, collect and analyze metadata for your master data. For all the sources identified in step 1, what are the entities and attributes of the data and what do they mean. So this should include the attribute name, data type, allowed values, constraints, default values, dependency, who owns the definition, and maintenance of data. Owner is the most important and often the hardest to determine. If you have a repository loaded with all your metadata, this step is an easy one. If you have to start from database tables and source code, this could be a significant effort. Fourth is appoint data stewards. These should be the people with the knowledge of the current source data and the ability to determine how to transform the source data into the master data format. In general, stewards should be appointed by the owners of each master data source, the architects responsible for the MDM softwares, and representatives from the business users of the master data. Fifth, implement a data governance program and data governance council. This group must have the knowledge and authority to make decisions on how the master data is maintained, what it contains, how long it is kept, and how changes are authorized and audited. Hundreds of decisions must be made in the course of a master data project, and if there is not a well-defined decision. 6. Develop the master data. In this, decide what the master records look like, including what attributes are included, what size and data type they are, what values are allowed, and so forth. This step should also include the mapping between the master data model and the current data sources. This is normally both the most important and most difficult step in the process. But if we try to make everybody happy by including all the source attributes in the master entity, you often end up with master data that is too complex and cumbersome to be useful. 7. Choose a toolset. You will need to buy or build tools to create the master list by cleaning, transforming, and merging the source data. You will also need an infrastructure to use and maintain the master list. These functions are covered in detail later in this article. You can use a single toolset from a single vendor for all of these functions, or you might want to take a best-of-breed approach. In general, the techniques to clean and merge data are different for different types of data. So, there are not a lot of tools that span the whole range of master data. The two main categories of tools are Customer Data Integration or CDI for creating the customer master and Product Information Management or PIM tools for creating the product master. Some tools will do both, but generally, tools are better at one or the other. The tools should also have support for finding and fixing data quality issues and maintaining versions and hierarchies. Versioning is critical because understanding the history of a master data record is vital to maintaining its quality and accuracy over time. 8. Design the infrastructure. Once you have clean, consistent master data, you will need to expose it to your applications and provide processes to manage and maintain it. When this infrastructure is implemented, you will have a number of applications that will depend on it being available, so reliability and scalability are important considerations to include your design. In most cases, you will have to implement significant parts of the infrastructure yourself because it will be designed to fit into your current infrastructure platforms and applications. 9. Generate and test the master data. This step is where you use the tools you have developed or purchased to merge your source data into your master data list. This is often an iterative process that requires tinkering with rules and settings to get the matching right. This process also requires a lot of manual inspection to ensure that the results are correct and meet the requirements established for the project. No tool will get the matching done correctly 100% of the same time. So, you will have to weigh the consequences of false matches versus mismatches to determine how to configure the matching tools. False matches can lead to customer dissatisfaction if bills are inaccurate or the wrong person is arrested. Too many mismatches make the master data less useful because you are not getting the benefits you invested in MDM to get. 10th, modify the producing and consuming systems depending on how your MDM implementation is designed. You might have to change the systems that produce, maintain, or consume master data to work with the new source of master data. If the master data is used in a system separate from the source systems, a data warehouse for example, the source systems might not have to change. If the source systems are going to use the master data, however, there will likely be changes required. Either the source systems will have to access the new master data, or the master data will have to be synchronized with the source systems so that the source systems have a copy of the cleaned up master data to use. If it's not possible to change one or more of the source systems, either that source system might not be able to use the master data or the master data will have to be integrated with the source system's database through external processes such as triggers and SQL commands. The source systems generating new records should be changed to look up existing master record sets before creating a new records or updating existing master records. This ensures that the quality of data being generated upstream is good so that the MDM can function more efficiently and the application itself manages data quality. MDM should be leveraged not only as a system of record but also as an application that promotes cleaner and more efficient handling of data across all applications in the enterprise. 11. Implement maintenance processes. As you can see, MDM is a complex process that could go on for a long time. Like most things in software, the key to success is to implement MDM incrementally so that business realizes a series of short-term benefits while the complete project is a long-term process. Additionally, no MDM project can be successful without the support and participation of the business users. IT professionals do not have the domain knowledge to create and maintain high-quality master data. Any MDM project that does not include changes to the processes that create, maintain, and validate master data is likely to fail. Let's now proceed to the creation of a master list. Whether you buy a MDM tool or decide to build your own, there are two basic steps to creating master data: the cleaning and standardizing data and matching data from all the sources to consolidate duplicates. First is the cleaning and standardizing data. Cleaning the data and transforming it into the master data model is very similar to the extract, transform, and load or the ETL processes used to populate a data warehouse. If you already have ETL tools and transformation defined, it might be easier just to modify this as required for the master data instead of learning a new tool. Some typical data cleansing functions are normalized data formats. In this, make all the phone numbers look the same, transform addresses, and so on to a common format. Replace missing values, defaults, look up ZIP codes from the address, look up the Don and Bradstreet number must be inserted. Standardized values where we can convert all measurements to metric, convert prices to a common currency, change part numbers to an industry standard, map attributes, parse the first and last name from a contact name field, then move part number and part node to the part number field. Most tools will cleanse the data that they can and put the rest into an error table for hand processing. Depending on how the matching tool works, the cleansed data will be put into a master table or a series of staging tables. As each source gets cleansed, you should examine the output to ensure the cleansing process is working correctly. The next basic step is matching data to eliminate duplicates. Matching master data records to eliminate duplicates is both the hardest and most important step in creating master data. False matches can actually lose data. Two Acme corporations become one, for example, and mismatches reduce the value of maintaining a common list. As a result, the matching accuracy of MDM tools is one of the most important purchase criteria. Some matches are pretty trivial to do. If you have social security numbers for all your customers, or if all your products use a common numbering scheme, a database join will find most of the matches. This hardly ever happens in the real world. However, some matching algorithms are normally very complex and sophisticated. Customers can be matched on name, maiden name, nickname, address, phone number, credit card number, and so on, while products are matched on name, description, part number, specifications, and price. At this juncture, let's now proceed to the second technique in data warehousing, which is the SOA, or the service-oriented architecture. Service-oriented architecture is a design philosophy about how to structure a solution. It entails integration across systems, and it makes systems more flexible in terms of business needs, simpler to develop further, and easier to maintain and manage. In SOA, a number of services communicate with each other in one of two ways, either through passing data or through two or more services coordinating an activity.
For example, we have a software which is the service consumer, and it talks or communicates to the other software which is the service provider. So the consumer software sends a service request or a message to the provider software. Then, the service provider software replied with a service response to the service consumer software. When the request is received by the service provider software, it is processed by a service. So what is a service? Service is a program which the user can interact through well-defined standards for the exchange of messages, and must be designed for stability and accessibility. The consumer software needs to know how to call in service and what to expect in response. And it is important to know that SOA is a solution for making two software communicate to each other.
And there is a software architecture which connects all the services together, called the service bus. It acts as a communication center in the SOA by allowing linking multiple systems, applications, and data, and connects multiple systems without disruption. So there are lots of benefits that we can get in service-oriented architecture. Some of these are greater business agility. It makes our business to market faster. Ability to leverage legacy functionality in new markets, and it will improve collaboration between business and IT. Next, we will talk about how our data should be accessed. We have tackled the typical ingredients in a data warehouse solution in this chapter. When we examine a data warehouse solution in relation to the various information domains introduced in Chapter 4, we can see some interesting correlations. There are two types of direct users of a data warehouse: the BA analyst, which always makes his or her analysis based on business needs, and the business user, which is always the end user. When a business user approaches a BA analyst for help with data warehouse access, he or she may be doing so for one of two reasons. The first reason is business user may be looking for more than mere information. He or she may also need an analyst to interpret the information. This means that the analyst must have business insight in what has been said in Chapter 4. The other reason is that business user does not have access to the desired data and is looking for information. As shown in Exhibit 5.13, the analyst frequently has numerous points of entry to the data warehouse. The reason is not because the analyst must know more than the rest of the company, but that a data warehouse is a thing that changes all the time to adapt to the business requirements or needs. Furthermore, because the business may require some time to recognize and formulate a new need for information, and there will be standard reports containing the required information, there will be a period of implementation during which the analyst will deliver the manual reports with the necessary information. So we have here access to BA portals. Analysts don't actually need to access to BA portals because if they do, they can gain direct access to the data they are retrieving through their analytical programs. When someone from the business requested a report, the analyst can refer to the data managers in the section of the data warehouse responsible for report development. However, in smaller organizations, the roles of data managers and analysts are typically performed by the same person, indicating that it does not make sense to separate the two roles from the start. Next, analysts will often make considerable use of BA portals. Because they provide quick and easy data access, analysts are obviously not using this data in connection with the ongoing development of manual reports. Because if there is a front-end access to the required information, the end user can retrieve the data there themselves. Next, analysts will typically use a BA portal in connection with the development of new reports, scorecards, or dashboards. In cases where any of these are deemed too complex for the end user to develop, they are then delivered to end users who can then continuously update the contents of the reports as new data is entered into the data mart or on request. Analysts use front-end solutions in connection with the validation of data drawn directly from the data warehouse. If an analysis is based on a linkage of 5 different extracts collected via SQL directly from the data warehouse, hundreds of lines of programming will typically be required to validate. Of course, this will not be a one-to-one validation because the analyst would only have used front-end solutions. However, it could be in connection with segmentations based on information available only from the data warehouse and not from the data marts where we want to validate that we have included all customers in our analysis. As a result, we want to compare the number of segmented customers to the total number of customers. If these two figures are not the same, we have a segmentation error. Analysts must train their end users in the functionality provided by the BA portal because they frequently have a high level of contact with the people who make decisions based on data warehouse information. Next, let's proceed to access to data mart areas. It's tempting to argue that analysts don't need direct access to data marts if they already have access to data through BA portals. The idea here is that data can be transferred to the front end and saved as a flat file that can be imported into a statistics or data mining program. However, There are several arguments against this. First, it's important to be able to automate processes. It is in contrast to manual processes in which the analyst retrieves, saves, and imports data through physical routines. Second, in connection with data mining solutions, where the same data must be presented in the same format month after month, automating such processes can result in significant savings. As a result, the analyst must decide whether to spend his or her time. It's either moving data around or analyzing it. And third, front end can function as an SQL generator. If our analyst expertise does not specifically include SQL development, SQL requests can be generated in the front-end solution and copied and pasted into a statistics program, which can also use the front-end solution's access to the data mart. We can automate data delivery via Open Database Connectivity or ODBC entries in this manner and ensure that it is difficult enough for our analysts to stay focused on analytics. In the context of data mining projects, where data access can be a significant time consumer, this specifically means that data access can be completed faster if we focus solely on easily accessible information from our data marts. Once our data mining processes are in place, we can begin collecting more raw data directly from the data warehouse. Moreover, this approach supports what is generally recommended when establishing BE projects: think big, start small, and deliver fast. Next, the access to data warehouse areas. Access to these areas enables analysts via front-end solutions to provide the business with answers that they may otherwise not get. It is not a question why only analysts have access to certain data concerning the withholding of data. It is a matter of establishing front-end solutions that present information in the most user-friendly manner based on the needs of the users and the skills of the business users, generally speaking. There are several reasons why a company or business needs answers to questions that cannot be answered through the BE portal. And these may change over time. Questions may arise in connection with ad hoc tasks that do not require regular reporting. A business may want to implement complex analytical solutions. Data mining is generally associated with a business looking to use information as a strategic resource, not because the analytical method as such can justify this, but because it is a strategic decision that forms the basis of the investment in this competence area, while data miner is the person driving the solution. As a result, more complex data mining projects rely on the data miner or analyst having direct access to the data warehouse. Furthermore, the results of data mining process are typically distributed via the data warehouse to the CRM systems whose users are involved. Typically, data mining information is acted upon. Next, the access to source systems. It is something analysts do not always have if a data warehouse has already been established, and this is usually not automated, which is why people frequently associate significant time consumption due to the use of data obtained directly from source systems. Furthermore, data quality can be quite variable depending on how the data is used in the source system. Furthermore, source system itself might suffer in performance if accessed as a data warehouse. In these cases, if information of significant value is discovered in the source systems, a process will be initiated to ensure that this information is accessible in the data warehouse. If the company does not have a data warehouse, analysts must always work directly with source systems, despite the limitations. Over time, an analyst will usually want to run regular reports every month. The data set generated from this can thus be viewed as a data warehouse at the most basic level and as a quantity to be optimized. In this chapter, we discuss how to best store data to support business processes and thus the demand for value creation. In addition, we also tackle the architecture and processes of a data warehouse. BA is impossible to achieve without access to a combined data foundation. From the data creating source systems of the organization, that is correct and precisely what a data warehouse does. It improves usability and the availability of source data. It will be discussed further in Chapter 6. So that's it for the Chapter 5. We hope that you have learned from us.